Okay, and here the potential energy we can get from the work done between two charges, which is equals to delta V into Q V naught, means when two charges are separated by certain distance, okay, at a separation R, the potential energy between the charges is 1 by 4 pi epsilon naught into Q by R. Okay. While solving the numericals also, we discussed about this concept, right? And there, number of pairs are also to be taken into account. Okay. Yes. Right. Then here I am recording the video. And here, suppose one small example, like that day what I asked, how many pairs are there for a square of side length? And 1, 2, 3, 4 charges are placed. What is the potential energy of the system? Okay. The day you told the potential energy of the system is equals to the number of pairs we have to count. You said 2, 3, 4 pairs, and the diagonal also the day you told 2 more pairs. Okay. So here, if we see, right. Here, if we see the total potential energy of the system, 1 by 4 pi epsilon naught, here between these two charges Q1, Q2 by A. Better I take 1 by 4 pi epsilon naught common in all. Plus between these two charges Q2, Q3 by A. Plus Q3, Q4 by A. Okay. And here between those two charges Q1, Q4 by A, the sides are over. Now coming along the diagonal pairs are plus Q2, Q4 by the distance is not A, it is root 2A. So root 2A, the length of diagonal. And here across this diagonal also plus Q1, Q3 by the separations root 2A, which is the length of diagonal. Okay, just I gave the example here how to get the potential energy between the charges. Okay, and then here Nana, in this case of potential energy, okay, suppose if they ask, find out not potential energy between the system, find out the potential energy of, better you take one hollow speed. Which one? What we say, the self-potential energy. Okay. Self-potential energy means the potential energy of the sphere when you give some amount of charge. Okay. First we ask why it gets some potential energy, sir. First thing is, suppose if you give some amount of charge at an instant. Okay. This is the charge given. This charge, since it is hollow sphere, whether conducting or non-conducting, okay, the charge resides over the surface. Further, if you want to supply some amount of charge, which should be spread over the surface, okay, that charge, whatever you are adding, positive charge, is not accepted by the existing charge on the surface. Okay, not accepted by the existing means existing is also positive charge. You are trying to add the positive charge, so if it does not accept that positive charge, whatever you are adding, that's why what happens here, there will be some repulsive force. That's why you won't accept. At that time, to add this charge to the sphere, we have to do some work against the potential over the surface. That work done, already we discussed, is in the form of potential energy. That potential energy is named as self-potential energy. So here, what I am saying, already some charge is there over the surface of radius r, of course, of this sphere. By the charge, it has some potential on its surface. V is equals to, all we know, 1 by 4 pi epsilon naught q by the radius is r. It is the potential over the surface of a sphere. Okay. And you are adding means according to the definition of potential energy, we have to bring this one from infinite distance to here. At infinite distance, generally the potential, electric potential is zero. That's why potential difference between those two delta V is equals to 1 by 4 pi epsilon naught q by r. Okay. Then here what happens if you see there, at that potential difference, you are adding the charge. So we are doing some amount of work according to which formulas are delta V into Q. Okay. Look at here now, delta V is 1 by 4 pi epsilon naught Q by R into Q, whatever you are adding, that is a dQ. By adding some amount of charge, the Q value continuously change. So it is not a constant. That's why to find out the work done, we have to use the integration. Okay. So there, what is the total work done, sir? If you see, then here you look at it is very simple. Why? Because these things are constant taken out. That equals to, I write here 1 by 4 pi epsilon naught. Q is not a constant. Why? Because you are integrating with respect to dq. Divided by r, it is a constant, which is the radius of the sphere, into the leftover term inside is q into v. Okay. Then here, if you see, this is equals to what we are getting 1 by 4 pi epsilon naught r into q into dq, like x dx. So you will get x square by 2. In the same way here, you will get q square by 2. Okay, it is the integration. And here you are adding the charge from what limit to what other limit. Means initially there is no charge on the sphere. So initial charge is 0. And finally by adding and adding and adding continuously, you suppose you are raising the charge to capital Q. So the final, therefore, here what you are getting 1 by 4 pi epsilon naught into r into first upper limit 2 square by 2. Lower limit, no need to substitute. Why? Because it is 0. Okay. Therefore, the work done, what I am getting here is 1 by 2 fours are 8, 8 pi epsilon naught r into q square. That is 1 by 8 pi epsilon naught q square by r. That work done, here already I defined it as self-potential energy. So it is the self-potential energy of the hollow sphere. Okay. And here the advantage of learning this concept is, previously in one assignment I gave one question related to soap bubble. Suppose this is one soap bubble of radius r, and you are giving some amount of charge to its surface. Okay. First, what happens? So bubble is some elastic type of surface. Why? Because when you give the positive charge due to the self-repulsion, you will get here what that radius try to increase, means the soap bubble will try to expand. Okay, and don't get confused whether you give positive or negative. Okay, means suppose if you give the negative charge to the soap bubble, which is distributed over the surface, again due to the self repulsion, negative and negative, again the bubble tries to expand. That's why whether you give the positive charge or negative charge, the radius will be increased. Okay. In this case, what will be the electrostatic pressure? Okay. If they ask, there I can use this formula to find out the electrostatic pressure. Okay. How to use? Later I will explain. First, in the meanwhile, take the points now. And if you have any doubts, you can ask. Yeah. Suppose if I ask, due to the charge present over the surface, what is the pressure? Means additional pressure. Already existing pressure, all of you know. Okay. That is delta P inside a soap bubble is equals to, means delta P in a soap bubble equals to, all of you know in your first year, that equals to 4T by R, nothing but 4S by R. I think you remember where S is the surface tension. Okay, from fluids, mechanical properties of fluids chapter. Now, due to the charge present over the surface, what the additional pressure you get? That is the question. Okay, and for that, very simple what I am saying here. Suppose if you take potential energy per unit volume, okay, it is actually called as energy density. Okay, and here that potential energy per unit volume is nothing but the pressure, additional pressure, whatever you are getting. Means potential energy is nothing but force into displacement. Volume is actually, this is in meter cube. Okay, so you are getting Newton per meter square. If displacement unit is meter, force unit is Newton. Okay, Newton meter by meter cube, that is Newton per meter square, right? So by this you can calculate what is the pressure acting over the surface. Okay, if you calculate that one, you will get finally that is sigma square to epsilon naught. Okay, right. Okay, and here we try to derive it later. Okay, even why? Because we have to discuss about the self potential energy of solid sphere also. Okay, later I will prove that why it is equals to sigma square by 2 epsilon. Okay, Nana? Solid sphere means if it is conducting solid sphere, again the charge will reside over the surface only. That's why again the concept will lead to the same thing here, whatever we derive. So I am taking this one as non-conducting solid sphere. Okay. So I am going to derive here what, Nana? Non-conducting solid sphere. Okay. For this, what will be the self-potential energy? Okay. If it is a non-conducting solid sphere, the disadvantage previously we discussed in Nana, charge given to the sphere not only resides on the surface, but also spreads to the all parts inside. That's why if the distribution is uniform, immediately we write rho, the volume charge density, okay, is equals to What we write down? Charge per unit volume, Q by P, right? So here the disadvantage, if the charge resides only on the surface, then you can bring the charge to the surface only. Means whatever the amount of charge in this case you are taking, you are bringing to the surface only. Means final point is fixed there. Initial point is always fixed. Why? Because in all cases we bring the charge from infinity to this point. Okay. So always V1 equals to 0. There is no doubt. Okay. So we have to take V2. Problem is charge is distributing to its volume inside also means you have to the parts inside. That is the disadvantage. Okay. Here. So while giving the charge there, okay, to understand the concept, what I am going to do, this sphere I form like this. At an instant, the radius of the sphere is r. Okay. Instead of some dq here, I am taking that dq over another sphere. Okay. Whose inner radius is r and outer radius is r plus dr. Okay. So this radius is I am taking r plus dr. Means it is just like one hollow thick shell. Okay. This part is added over the existing sphere of radius r. By this what happened? Already it is solid sphere. Okay. Over it you placed one shell having certain thickness dr. If you add, it is also the charge part. After adding here, you are getting a solid sphere of radius r plus dr. What I am saying means you are not only adding the charge but also increasing the radius. That is the advantage here first. Okay. So in this case, I am adding like the thick shells, okay, of thickness dr, 1 by r, 1 by 1 more shell is added here like this of certain thickness, and one more I add like this here or having certain thickness. By adding, like I am forming all together one solid sphere of radius capital. Okay. To form the radius capital, instant to instant I am adding the charge means I am doing the work. Okay. Why? Because already is existing some q is there and you are adding plus dq there. Again, q and dq repel each other. Why? Because both are positive charges. So under the repulsive force, you are doing some work to place it here by bringing that one from infinity to here. Okay. That amount of work done, you have to calculate. Okay. So the work done is equals to generally what we write on delta V into Q. Okay. Right. Here delta V means at an instant I am taking its radius is R. Okay. It is having some amount of positive charge. How much? Let it be small q. Okay. Then here I am placing one more means you are bringing the other shell placed over the surface. Means here I have to find out the potential. Potential over the surface of solid or hollow sphere is V2, what I am saying, equals to 1 by 4 pi epsilon naught existing charge Q by its radius is R. Okay. And you are bringing this charge by assuming it as a dq. Okay. Means this part is a dq, whatever I added here. Okay. That dq I am adding and bringing that one from infinity. From infinity means V1 0. Therefore, delta V2 minus V1 I am getting 1 by 4 pi epsilon naught Q by R. And you are adding that dq. Therefore, work done is equals to delta V Q by R into Q. I am adding dq. Okay. There, if you are able to find out dq, later directly q dq means these two are variables, so we have to integrate. Okay. So here in this integration, I have to tell what is the amount of charge present in this part. Means I want to write that in terms of sigma. Means sorry, rho. Okay. So from this formula, what can I write here? 1 by 4 pi epsilon naught. Okay. Q is equals to I write existing charge. Q equals to, first I write from the formula rho is equals to YB. Okay. Q inside this part is rho into its volume. Volume of the solid sphere is 4 by 3 pi R3. Okay. And dq you will get by differentiating, or else if you have the idea, you can say dq is equals to rho into dv. Rho into volume, if you differentiate, you will get 4 pi r square dr. Okay. Why? Because this is 4 by 3 pi. R cube differentiation is 3r square into dr. By cancelling, you will get 4 pi r square dr. That is dv now. Okay. Means I am trying to differentiate that one in terms of the rho, constant rho. Okay. So here, if you see by writing that dq, substitute here, Nana. W is equals to, straight away I am putting the integration here. Integral 1 by 4 pi epsilon. Okay, better I take 1 by 4 pi epsilon naught constant taken up into Q. Q I am writing here rho into 4 by 3 pi r cube. Okay, this part is over. Rho Q part by r. Okay, into dq. dq, whatever I got here, I substitute rho into 4 pi r square into dr. Okay. Then here, once you check, Nana, 4 pi here cancel. Then you are getting rho constant, 2 rows are there. So rho square taken up by epsilon naught. Okay. Then here 4 by 3 pi constant, 4 by 3 pi taken up. And here cancel r square means you will get 1 r there into integral of, all together you are getting what? R power 3 and r is r power 4 dr. Okay. Then look at here, Mama. This is rho square by epsilon naught into 4 by 3 pi into that integration of, r power 5 by 5. Okay. Look at here. We are finally increasing the radius by adding these shells to what value? Capital R. So you are increasing the radius from 0 to capital R. So limits are, here I substitute 0 to r. Then you will get 4 pi rho square by 3 epsilon naught. Of course, 5 I multiply. 5 3s are 15 epsilon naught into r power 5. This is the work done, what I calculated here, Nana. That work done is the work by adding the charge here to a solid sphere. So that work done is defined as, again, the self-potential energy U equals to 4 pi rho square r power 5 by 50 epsilon naught. This is of solid sphere. Look at these two are not equal now. Solid sphere and hollow sphere, you are not getting the same formula. Okay. That's why the self potential energy of hollow sphere like soap bubble is not equal to the potential energy of solid sphere. Okay? Right. So if you see here, rho is equals to in terms of the final charge and radius. Okay. Then I can substitute rho square equals to, by taking 3 to the numerator. 3 square means 9 q square by 4 square means 16 pi square into r cube square means r power 6. By squaring this term, I will get rho square term. Then I will substitute there in the self potential energy of non-conducting sphere. U equals to 4 pi r power 5 divided by 15 epsilon naught into rho square. I am substituting 9q square by 16 pi square r power 6. Okay. The terms which are comfortable, first cancel them. Nana. Pi cancel. 4 4s are cancel here. And r power 5 means only 1 r. Okay, will be there. And here I can these are 3 5s. Okay. Then look at here, Nana. You are getting finally what? 1 by 4 5s are 20. Pi epsilon naught into 3q square by r. Okay. Any mistake here, Nana? I committed. This is equals to 3 by 20 pi epsilon naught into q square by r. This is the self potential energy of what? Conducting sphere, sorry, non-conducting solid sphere. And this is the self potential energy of either conducting solid sphere or conducting or non-conducting hollow sphere. This is 1 by 8 pi epsilon naught. This is 3 by 20 pi epsilon naught. Try to remember these two. Why? Because many times we have to use when solving the numericals. The self potential energy of non-conducting and the self potential energy of conducting. Okay. So here, if I erase this part, okay, and then what I asked previously, in this case, the pressure, okay, means pressure due to the charge present. I can calculate here according to the formula what I erased, the self potential energy per unit volume. Here, why I am coming to this concept of non-conducting sphere? Why? Because the charge is present in the volume. Whereas in that case, Nana, the charge present over the surface only. That's why there I gave the pause and now I am deriving. Okay, I think you understood. This potential energy here is equals to 3 by 20 pi epsilon naught into q square by r divided by, this q is present over the total volume. Volume is 4 by 3 pi r cube. Okay. So if you bring the terms here, if you cancel first, okay, right, I write 3 3s are 9 by 20, 4s are 80 pi square epsilon naught into q square by r cube into r, that is r power 4. Okay, this is the pressure whatever I see over the surface. Okay, that one will you write in terms of sigma in case of there what we got. Okay, so in case of soap bubble, sigma is equals to what we write now? Q by area, charge per unit area, that is capital Q by area. Capital Q by area is what? 4 pi r square. Okay. Here, yes. Take Q square now. Q square, sorry, sigma square, if I take, which is Q square by here 60 pi square r power 4. Okay. Then sigma square by epsilon naught you take now. You will get Q square by 16 pi square epsilon naught r power 4. Okay. Then divide with the 2 nana, sigma square by 2 epsilon naught is equals to Q square by 16 2s are 32 pi square epsilon naught r power 4. Okay. This is what I am saying, the pressure in the soap bubble. Okay. Pressure in the soap bubble in case of the hollow sphere and in case of the solid sphere. Okay. Means suppose if there is a inside, this will be the total pressure that it exerts at the surface, and this is the pressure in case of hollow sphere. Understood, Nana? This is the story about the pressure concept and the self potential energy. Right? In solid and hollow sphere, in both the cases I explained here. And then I am coming to here. Suppose just I am leaving one question to you all, try to solve it. Two dipoles, this is one dipole of length, generally we take it as 2L. Okay, of dipole moment P1, and another dipole is placed on its axis and the directions are taken in opposite. Okay, this is P2. Its length is 2L. What is the potential energy between the dipoles? Okay, better to solve them easily, considering them as short dipoles. Consider both P1 and P2 are short dipoles, so that you will get the answer very easily. And the separation between the center to center is R. Okay. Why I am giving this question here? Already you solved in one assignment the potential energy between two dipoles. Okay. So here using this concept, try to solve it, Nana. Means W is equals to delta V into Q model. Okay. Try to solve it. Okay. Right. This is one story of dipoles. By this, we completed the concept of the potential and potential energy. Okay. Then we have to enter into a new concept of this chapter, that is capacitance. Okay. In the meanwhile, take the points and ask if you have any doubts here. What is meant by the capacity first? Okay. Simple to understand, I can say that suppose it is one glass now. Okay. In the glass, what is its capacity if I ask? You say, sir, to measure the capacity, first you pour some quantity of liquid, sir, like water. Okay. And you fill that glass with the water to certain level. Okay. And still you pour. Then water comes to the brim here, and further what happens if you add the water further, then the water will overflow. Okay, means its capacity is measured in this case with its dimensions like volume. If you measure the volume of glass as say some 10 cc, its volume is, okay, then I can say, Array, you can fill the chai or coffee or water in that glass, only 10 cc. Further, if you pour, then it will overflow. Okay, this is the measure of capacity now. Okay, in the same way, here also one problem will be erased. What is that, sir? Suppose if you take one conductor now, take a conductor. Okay, then for this conductor, say some shape, any shape, okay, like a sphere. Okay, for this conductor, here I am adding the charge. Since it is a conductor, the charge resides over the surface. Okay, now my question is, whatever the charge you are adding to the surface, why it is not leaking into the surrounding medium? Okay, if I ask this question, you can say, sir, generally the surrounding medium, what we take? Air. Okay, air is not a conductor, sir. It is an insulator. Okay, it is an insulator means you are giving the charge to a conductor, means the conductor is a good fellow. Okay, taking the charge and ready to give to someone if they take. Okay, but the surrounding medium here around the charge is not the supporting medium. Why? Because it is air, it is an insulator. Insulator is a property is always what we say, it does not, means not does not. What I'm saying, it is not interested to take the charge, it is not interested to supply the amount of charge. So here problem raised is, even though the conductor, after giving some amount of charge to the conductor, okay, it is trying to give the charge to the surrounding medium, but the medium is not taking. That's why here the charge on the surface is not overflowing into, means leaking into the air, not leaking into the air. Okay, then we can ask, not leaking means, can we add any amount of charge to it, sir? Means even can we add infinite amount of charge to a conductor? Then I say no. Okay, you can't add infinite amount of charge. Then immediately from your side, you can ask one question. Why not, sir? Why? Because given any amount of charge you are giving to the conductor, that conductor cannot supply the charge to the insulator, the surrounding medium. Why? Because insulator is not interested to take the charge. Okay. So here the charge should not overflow from the surface according to the concept. Okay. If it is so, then in nature, many times we observe from the clouds lightning. Lightning is what actually, due to the friction between the layers of cloud, some large amount of charge is generated, and that is, suppose the amount of charge generated leaks into air. Okay, that charge immediately tries to search for a good conductor, since Are you able to get the video, Nana?
It is buffering.
Now, then what I'm saying here, suppose at the clouds, due to the friction of different layers, lot of charge is generated in large amount, and that charge generated at the clouds, suppose leaks into air. That leakage of charge from the clouds, we call it as lightning. That we see in the shape of one spark. Okay, one thread, lightning thread. Okay, that thread very quickly reaches to the earth. Okay, why it is reaching to the earth from clouds? Earth is a very good conductor. Okay, to the earth. Conductor, what is its property? It can take any amount of charge, it can supply any amount of charge. That's why whatever the charge leaking from the clouds will come like a lightning to the earth. Okay. So practically what we are seeing, the leakage of charge, even though in between clouds and earth, actually what is there? Air. Okay. Air, according to the concept, it is an insulator. Insulator means whatever the charge leaked into air should not be taken by the air, and that should not be sufficient.
Sir, your voice is breaking.
Now, Nana?
Sir,
My question is, the charge that leaks from clouds, how it comes to the earth if the air is an insulator, according to the theory. Okay. For that, what he is saying, any medium in the nature has some sustaining capacity not to leak the charge, means not to flow the charge through it. Okay. That capacity of a medium not to allow the flow of charge is called as breaking strength. Okay, like the stick to break, it has some strength now. Okay, you have to apply more than that strength, then only the stick will be broken. In the same way, here the conducting property of a medium, okay, will be broken. Sorry, not conducting, insulating property. Insulating property. Insulating property means not allowing the flow of charge. That insulating property will be broken at certain point of charge. Okay, that the strength of surrounding medium is called as breaking strength. Okay, then you raise the question, how to measure the breaking strength of a medium, sir? That breaking strength you measure with breaking the electric field intensity over the surface. Okay, if the electric field intensity over the surface is sigma by epsilon naught, then the breaking strength, that implies breaking strength of surrounding medium, is equals to sigma by epsilon. Okay, so I think you understood. Beyond certain level, the insulating property, not taking the charge from the conductor, that property will be broken, and the medium, that is air, allows, insulation property is broken, means it behaves as a conductor. Means the air behaves as a conductor beyond certain level, what I said, beyond certain level, it allows the flow of charge and behaves as a conductor. Okay, at that instant, the air medium is behaving like a conductor, means it is very dangerous now. That's why here, while the lightning, it is allowing the charge, means lot of charge is coming to the earth during the lightning. That's why all the surrounding part of the air is behaving like a conductor. Suppose you are in that vicinity, Okay, lightning is falling here. Suppose you are there in its vicinity, then immediately you are in the conducting medium. You are in a conducting medium, and human body is also a very good conductor. Keep in mind, our body is very good conductor, Nana. So you are a conductor, and the conductor is in the conducting medium. Immediately you are in a position to take the charge. That's why the lightning will fall off. So that lighting will fall means lot of charge is accepted by the human body. That charge while flowing through the human body means like through human blood cells, it tries to kill all the blood cells and instantly the person will die. That's why here it is very dangerous, Nama. We should not stand very close to the regions where the lighting are falling. Okay, that's why not to fall that lighting for our houses, we keep the lightning conductors above our house or apartment. Okay, to prevent ourselves. That's why during the lighting time also we should not come out of our house. Okay, why? Because human building already due to the rainfall, it is wet, and our building behaves like a good conductor, all the walls and all. If it is a good conductor, the electric field intensity inside equals to 0. That's why you are in a safe region where there is no electric field without touching the walls. I think you understood my intention. That's why even in our daily life also, according to the concept, don't come out of your house during the lightning. Okay, so from that concept, what I said here, you can't give infinite amount of charge to a conductor. Okay, you can give the charge to a conductor to certain level whose field intensity is equal to the breaking strength of surrounding medium. If these two are equal, the field intensity over the surface and the breaking strength both are equal, then immediately it is in a position like this, filled with the water up to the brim, means ready to overflow. Here also it is ready to leak the charge from its surface. Okay, and further if you add, if this field intensity is equal to the breaking strength, at that instant if you add the charge to the surface, it leaks into air. Okay, that leakage sometimes we see in the capacitors or at the transformer. Okay, during the rainfall, means raining time. Understood? Then how to measure the amount of charge that you can give to a surface? Okay, and how to measure its capacity to take the amount of charge? That I will explain in next class, means tomorrow morning. Okay, so today's class is over.